far as factoring goes, it actually starts with multiplying. So here's what I need everybody to do. You should have a sheet of paper, something to write with, something to write on. And I want to talk about what multiplying two binomials should look like. So I want everybody to do 3x minus 4 and 2x plus 3. So I want you to write that down, or just write down the answer. Once you multiply that out, do the electronic raise hand, and then I'm going to talk about it. Okay, so I realize there's going to be some lag time from when you write it down to come up with your answer, but even then, if this is taking you longer than 5 seconds to multiply out, that's a problem. I'm not saying, you could still get the answer right, but we need to do it very efficiently. So if this is what you're doing, so when you look at this, when you multiply it out and you say, okay, like you do FOIL or whatever, you do this times this, that gives you 6x squared. You do this times this, that gives us a plus 9x. You do this times this, gives us negative 8x. You do this times this, gives you negative 12. And then that gives us 6x squared plus x minus 12. And if that's what you did, you got the right answer. Unfortunately, this isn't fast enough. This is what you do in pre-algebra or in Algebra 1. Once you get to Algebra 2 and beyond, if you're having to write this middle step out, that is way too slow. Also, if you're writing this middle step out, I'm willing to bet that you may have some trouble factoring. So I want to talk about how I want you to think about this so you go directly from here to here without this middle step. So one thing to keep in mind is when you're multiplying two binomials, you're going to get 3 terms most of the time. And since you know you're going to get 3 terms, let's make sure we know what those 3 terms, since we know we're only going to have 3 terms, we can there's things we can skip here. Like, for example, if you think about that first term, well, that first term came from multiplying these 2 things together. You think about your last term. Well, where'd the last term come from? That came from multiplying these 2 things together. So of our three terms, 2 of them you can easily get. You just multiply these together, multiply these together. Now, where the thought or the speed comes in is determining your middle term. And your middle term comes from, you came from the 9x and the minus 8x, and where that comes from is, and I look at it as this times this and this times this. So in my head, I look at it and I say, all right, I got a minus 8x and I get a plus 9x and I get my x. Now, let's look at this with a fresh problem. If I have 5x plus 3 and 2x plus 1, now with this fresh problem, I want to talk about how I want you to think about it. All right, when we multiply this, we know we're going to get 3 terms. And how we're going to, since we know we're going to get 3 terms, let's go ahead and write those 3 terms down. The first term and the last term are easy. The first term comes from this times this. So if I multiply this times this, well, that's going to give me 10x squared. I get the last term. That's going to come from this times this. Well, 1 times 3 gives you 3. It's actually plus 3. Now, the tricky part is the middle term. And our middle term is going to come from this times this and this times this. So if I look at it, that gives me 6x and 5x. So 6x plus 5x gives me plus 11x. And now what's happened is I've started with my multiplying 2 binomials and I've got my 3 terms. So here's what I want. Right now what I'm going to do is give you 4 problems. And I want you to practice multiplying those 4 problems this way. Right? Yes, I know you can get the answer if you do the whole FOIL thing and write all the steps out and come up here. The problem is doing that isn't going to help you factor, right? What I'm doing is building a skill so that you can become fast and very efficient at factoring. And the key part of that skill is getting from here to here without that middle step. So here are your 4 problems. And you don't have to write them down, but I do want you to write down the answers. And when you write down the answers, do the electronic hand raise. Okay, so I want everyone to write these 4 problems down, or if you want to, just write down the answers. But I want everybody to write those 4 answers down, and I'm going to press pause. All right, so this is how I multiply them. I look at this and I know I'm going to get 3 terms. So my first term is x squared, my last term is 12. I get 3x plus 4x gives me a plus 7x. I move on. For this one, my first term is going to give me 6x squared. My last term is going to give me a negative 12. And then I look at this as 9x minus 8x. So I get plus x, and I move on. I look at this problem. My first term is 3x squared. My last term is a negative 10. I get 15x minus 2x gives me plus 13x, and I'm done. Then I get 10x squared, the last term is plus 6, and I get minus 4 minus 15 is minus 19x. All right, that's the speed that you need to be able to do it at. In years past, when I do this exercise, as painful as it is, I would actually start the class and I would give you like 20 of these problems to multiply out. And the whole idea is I need you very, very good at multiplying, because factoring is harder than multiplying. Just curious, show of hands, is this how you multiplied before today? Do the electronic raise your hand. How many people just wrote down the answer? Okay. So hopefully you're finding this is a little faster, right? And this is all about understanding, because, yes, you can do FOIL and you can, multiply that out. I want to make sure we understand, that, okay, this first term is caused by these 2 things, this last term is caused by the last 2, and the middle term you got to think a bit. All right, so how does this impact what we're doing, right? Because our goal is factoring. So factoring, here, we'll start off with the easy ones, and usually everybody gets these. I get x squared plus 8x plus 7. And again, it might be boring some of you, but I want to talk about factoring. Now, I know a lot of people, like some teachers will draw this little X thing and then you start figuring stuff out. And that kind of works, but it doesn't work when there's a number in front. So we're going to sort of reverse what we were doing when we were multiplying. Now, so pretty much anytime you see x squared and x and a number, you're going to factor. Today and tomorrow and Wednesday, I'm going to give you nice instructions that say factor. But for the most part, anytime you see x squared and x and a number, you factor regardless what the instructions are. Because 95% of the time, that's what you're going to have to do anyway. Now, and here's how I factor. I look at this and I say, well, I know I'm going to get 2 sets of parentheses, right? Because that's what happens. Whenever you factor, you get 2 sets of parentheses. And now you need to think about, what caused this? Well, that first term is caused from these 2 first terms multiplied together. And so you ask yourself, well, what times what gives you x squared? Well, the only thing that's really going to work is x. The next thing you ask is, what caused the last term? Right? Remember how when we multiplied, we wanted to figure out the first term and then the last term? Well, when you factor, you look at the first term and you think, what caused that? And you look at the last term and you think, well, what caused that? Well, what caused the 7? Not a lot of options. There's a 7 and there's a 1. And since it's positive, I'll put pluses in here. And now here's the important part. You check. See, what you've just done is you've put this down. You've created something that you know the first term and the last term match. Great. Now we have to make sure that our middle term matches. And your middle term came from this times this and this times this. So that gives you 7x plus 1x. That gives me 8x. I know it's right. Right? So again, this was an easy one. Let's look at a harder one. What if I gave you x squared minus 17x plus 72? The numbers are bigger, right? Right, so numbers are bigger. Still, we're going to do the same thing. We know we're going to get two sets of parentheses. And so with our two sets of parentheses, we asked the same questions. You know, what caused the x squared? Again, not a lot of options. So I'm going to put an x and put an x. Now we ask ourselves, what caused the 72? Well, 72, there's a lot of things. You could have 72 and 1, you could have 36 and 2, you could have 24 and 3, you know, tons and tons of stuff. Here's kind of my general, thought whenever you have tons and tons of things. Always pick like numbers that are kind of close together to start guessing, because sometimes you get lucky. So you think 72, well, okay, so I'm going to say what's that, 9 times 8, right? So I'm going to put a 9 and an 8 and an 8. So 9 times 8 gives you 72. Now it's a plus 72. So there's two ways to get positive. They're either both positive or they're both negative. Considering I've got a negative in the middle, I bet these are both going to be negative. And I see I've already made it where the first term matches. I've already made it where the last term matches. So I just need to figure out the middle term. I see if the middle term matches, so I multiply this times this, and this times this. So it gives me minus 9. It gives me minus 8. Oh, good. I got the minus 17. I know it's right. Right? So these are kind of the easier questions, and the reason they're easier questions is, well, the numbers in front. There's not a lot of tricky stuff going on. But what happens when it's not so easy? What happens if I give you 3x squared minus 16x plus 5? Like the first two examples, I could can those out and everybody would get those right eventually. I'm not here to really teach that part. I want to talk about how do you handle something like this. Now, just curious, because these are just things that I've seen. Whenever you were given a number, like a coefficient that's other than 1, do the electronic raise hands. How many of you were shown that you multiply 3 times 5 and then start doing stuff? I'm just curious. How many people were shown that? So one person, okay. Normally about half the class raises their hand saying they were shown to do this. And then when they do that, my next question is, okay, do you know why it works? And inevitably, nobody knows why it works. That's a problem in math. The reason that's a problem in math, if you just start doing things and you don't understand why, I call that magic. And the problem with magic is sometimes you might get it right, sometimes you'll get it wrong, and you don't know why, because, well, it's magic, right? What I like about factoring this way is you know it's going to be right. You should know if your answer is right or not. So, how do we approach this? Well, here's how we approach it. Well, anytime I see x squared and x in a number, it's two sets of parentheses. So I'm going to go ahead and put my two sets of parentheses. And now I start asking questions. I ask, well, I got it. This term came from these two things. And so I think, well, what times what gives me 3x squared? Well, again, not a lot of options. I got 3x and x. That's it. Those are the only things that are going to multiply to give you 3x squared. The next thing you ask is you say, well, what gives you a 5? Again, not a lot of options. 5 and 1. So I'm going to put 5 and 1. Now, since that's a negative, right, it's a positive 5, so they're either going to both be positive or both be negative. I'm pretty sure they're both going to be negative. And now here's the important part. right? Right now, you have created something that you know the first term and the last term match up. Great. The important part is we need to make sure that the middle term matches up. And first, so we have to determine, does the middle term match up? And that's this times this and this times this. And so when I look at this, I get minus 5x minus 3x. That's not 16, right? So here's what I know. This isn't right, right? I know it's not right. So how do you fix it? Well, turns out that when you have a number in front of the order in which you put these actually matters. Like if 5 and 1 doesn't work, what if you changed it so that it was a 1 and a 5? Now, if you think about it, well, okay, the first term still works, the last term still works, but what we need to check to see if our middle term works, and so we do, well, this times this is minus 1x, this times this is minus 15x, minus 1 minus 15 gives me the minus 16. I know this is correct. And that's what I need, that's the confidence I need you to have. When you factor, you need to know if it's right or wrong. Now, I do have another trick, but before I do that trick, I want you to factor this one. So I'm going to give you 4x squared minus 4x minus 4. And so I want everyone to write this down, right, and factor. I purposely tried to pick something that wasn't super obvious, right? Because you go through, and yeah, getting the answer is important, but what do you do when your initial guesses go wrong is even more important. So let's start. Oh, well, okay, it's parentheses. So we're going to do 2 sets of parentheses here and here. And you think, well, how do you get 4x squared? Well, pretty obvious. I mean, like you go, well, why don't we try 2x and 2x? I like that. Okay? And then you think, well, how do you get 15? Well, okay, 3 and 5. That seems fine. So I'm going to do 3 and 5, and that's a negative, so one's got to be positive, one's got to be negative. And now you think what you get. Oh shoot, I got it right the first time. Dang it. I want this to be minus, this to be plus. So you go through, and now when I look at this, let's check to make sure everything works out right. So when I go through this whole thing, let's say I make sure this times this gives me the 4x squared, this times this gives me the minus 15, yay. Now I got to check to see if my middle terms work out. So this gives me a minus 6, and this gives me a 10. So I get 10 minus 6x. That gives me 4x. Not quite, right? I need a minus 4. The great thing is, once you get the number right, if this is the wrong sign, you simply just make this a plus, make this a minus, and everything still worked, right? The first term still gives us we still get, this times this still gives us our first term, this times this still gives us our last term, but now I have 6x minus 10, which gives me the negative 4, all right? So, now, here's a trick. Let's do one that's harder. So let's say I give you 12x squared plus x minus 6. I need everybody to write this down, even if you're an expert and you've done everything in your head easily. I need everybody to write this down because there's a trick. And it's a very handy trick. Okay. So you've got 12x squared plus x minus 6. And on the surface, this is a bit of a pain. Right? This is a huge problem, right? Because if I do my 2 sets of parentheses, how do you get 12x squared? Well, there's lots of things you could do. You could do 12x and 1x. You could do 2x and 6x. You could do 3x and 4x. There's a lot going on, right? So I'm going to put something down that doesn't work, and we're going to find out it doesn't work very quickly, right? So my red marker doesn't write, or I would have put it in red because it's wrong. I think I'll just do purple because that in theory has some red in it. So I'm going to go ahead and put down, I'm going to say 6x and 2x. And I know that doesn't work. All right, so those of you who are experts in factoring, hopefully I've grabbed your attention because, well, how do you know it doesn't work, right? We haven't tried anything. All right, so I know that 6x and 2x doesn't work, and here's why. First, usually when you factor, the first thing you ask is there anything in common? And if you look, there's nothing in common. There's nothing I can factor out. Like there's no 2 I can pull out because there's a 1 in front of the x. Right? That's important. Now, let's think about the 6. Well, how are you going to break up the 6? And you think, well, 2 and 3. All right, I'll put the 2 and 3 down. So let's say I put the 2 here and the 3 here. I don't have to go any further. I know it doesn't work. And here's why. Do you see that there's something in common we could factor out? See, there's a 2 and a 6. I could factor a 2 out. Well, if I can factor a 2 out here, I should have been able to factor it out up here. And since I can't put a 2 here because then there's something in common I can factor out. So I know the 2 can't go here. All right? Well, what if I switch this and I make that a 3 and that a 2? Well, that really doesn't work because now I could factor a 3 out and I could factor a 2 out. Okay? Well, instead of 2 and 3, 6, you could do 6 and 1. Then I have a problem. Where can I put the 6? I can't put the 6 here because if I put a 6 here, there's a 6 in common I could factor out. Remember, I should not be able to factor anything out of this on this line. If I put the 6 here, there's a 2 in common. So I can't put the 6 here. So right now I can look at this and say, I've tried all of my options. 6 and 2 can't work. All right? I'm going to try another thing that doesn't work. I could try 12 and 1. I'll go ahead and tell you that doesn't work. Well, actually, there's a way it could. I'll talk about why. There is one combination that has a chance, but right. Let's try 12 and 1. Well, if I try 12 and 1, if I break up the 6, like say 2 and 3, I can't put the 2 here because then there's a 2 in common. I can't put the 3 here. There's 3 in common that I could pull out. If I did 6 and 1, technically I guess I could put the 6 here and the 1 here, but then I get some giant number. That doesn't work. So, after a whole lot of talking, I'm kind of stuck with 3 and 4. So I'm going to put a 3 here, and here's a 4. Now, here's the part that's incredibly helpful. If I want to break up that 6, 2 and 3, I want you to think about where the 2 and 3 have to go. Right? So if I break up, first of all, I couldn't do 6 and 1 because 6 can't go here and 6 can't go here. So I know the 6 doesn't work. But let's try 2 and 3. Can I put the 3 here? Right? I've got to put the 2 in either a 2 or a 3 has to go here. Well, I can't put a 3 here because the 3 is in common. So I've got to put the 2 here and the 3 here. That's a negative. Right? So I know they're plus, one's plus and one's minus. So I'll make this a minus and this a plus. I'm just guessing. I don't know if it's right or not. I don't care. I can fix it. And now I go through and I check. And how I check is, okay, I know the first term matches. I know the last term matches because I've created it this way. To see if the middle term matches, I multiply this times this, and then I multiply this times this. And now when I look at it, I get 8x minus 9x, which gives me a negative x. Close, doesn't work. I need a positive x. Well, that's easy to fix. I just make this a plus, and I make this a minus. Now, I did a whole lot of talking. The reason I did a whole lot of talking is this little trick is incredibly helpful. So, your turn. So what if I give you 6x squared plus 19x plus 15? And so I want everyone to factor this, and once it's factored, raise your hand. Do the electronic raise hand. So those hands are coming up a lot faster now than they were coming up at the beginning of class, that's a good thing. So when you set it up, you think, how on earth do you get a 6x squared? Well, I'm going to guess 2x and 3x. So I guess 2x and 3x. Right? Now you think, well, so we know that we matched our first term. I want to find out, well, how do I get the 15? Well, 3 and 5. Now you think about, where can the 3 go, right? I can't put the 3 here because then there's a 3 in common. So I got to stick the 3 here. I'm going to put the 5 here. And since everything's positive, I put a plus. And now the most important part is check to make sure the middle term matches. I get 9x, I get 10x, that gives me 19. It's factored and I know it's right. Like my biggest complaint with this method of multiplying the 6 times 15 and figuring stuff out, you can get an answer, but if I say, would you bet your life that it's right? I don't think many of you would, because you don't understand why, you may not understand why it works. All right? So, here, do I have one more of these? Oh, here, we'll try, no. So here's what I want you to do. I mean, I could do one more. I gave an assignment in OneNote, and it's like 70 factoring problems, and that's way, way, way too much. I know that. We've got about 10 minutes left in class, and here's what I want everyone to do. I want everyone to do the third column. So when you pull up in OneNote, it says like homework for 9-15, and it's this giant page. I purposely didn't say what it was because I kind of wanted people to listen to what I'm talking about. And so if you've already started, that's fine. I'm checking the third column. So it's like 3, 6, 9, 12, all of those. So that ends up being, I think 24 problems. So 24 factoring problems. Now, just so you know, this is the beginning. Like tomorrow, we're going to factor. In a perfect situation, you would be in class and you would be factoring, and I'd walk around and make sure that you're thinking about it properly. I can't really do that. But what I do need you to do is practice factoring, where you do the 2 sets of parentheses, you sort of write down what gives you the first term, write down what gives you the second term. All right? So I want everyone